let's call this electrochemistry practice test answers. Okay. The first two questions here are just about this notation. I'm hoping that you noticed this notation online, sort of clicked around and saw what it was about. It goes from anode to cathode pretty much. So you want to see the oxidation and then the double line to represent the salt bridge and then the reduction. So it's almost like it follows this like up and down path, like a little mountain in terms of charge. So it should be the oxidation followed by the reduction. So this first guy is this one, because you can see the cadmium from 0 up to +2, he's oxidized, so he's going to go first. And then the dimercury 2 down to mercury liquid, he's the reduction. Same deal here, let's see, who's oxidized? The aluminum, 0 up to +3. So we should see that happening first. Followed by the tin being reduced from 2 down to 0. Okay, for number 3, 2 half reactions and the potentials, and which of the net reactions is spontaneous? These are both reduction potentials. Some of these don't make sense at all. Like D shows both the magnesium and the nickel being reduced. That just would not happen, just not possible. And E, I hope that you really noticed how weird this is. We got 2 magnesiums, and they magically transform into 2 nickels, so that's no good. In C, they're both being oxidized. They're both going up in charge, so that is also no good. So those are impossible, so I don't even have to check the math on them. So for A and B, I just check the math on those guys. Let's see. In A, the magnesium is reduced, so I take its voltage the way it is on the reduction, which is a negative 2.37 volts. I'm already thinking this is bad. The nickel is oxidized, so I take his reduction, I flip the sign on it, so I get a positive 0.25 volts. I'm not even going to bother adding that up. I can tell that it would be a negative voltage, and that's no good. And if I flip everything, both of those numbers are flipped. So if the magnesium is oxidized, then his reduction potential becomes a positive 2.37 volts. And the nickel is reduced, so his stays as a negative 0.25 volts. And that will be a positive voltage. So that will be the right answer. 3 will be B. Okay, for number 4, we're just going to find them here, put them together. Okay. There's the tin 4 being reduced to tin 2. Be careful, there are other ones that involve tin. So that one is the way it is, so the positive 0.15 is what we want. And then K, being oxidized from 0 up to +1, well, here's the reduction version of that. So we'll flip the sign on that, and we'll take a positive 2.93. And we will get that guy, positive 3.08 volts out of it. Okay, very similar situation here. The aluminum is reduced. He's right here. Negative 1.66. And the cadmium's oxidized from 0 up to +2. Here's the reduction of cadmium 2 down to 0. Negative 0.4, so I'm going to flip that and make a positive 0.4. This would not be spontaneous, but they didn't really ask me about that. They just asked what the standard potential would be. And it would be negative 1.26 volts. Okay. In this case, they give you the overall potential for the reaction. They give you one of them on this table and ask you to find the other one. So it's just like instead of adding them together to get your overall, you know your overall and put an X in for one of the other guys. Let's see. This is the overall, 0.38 volts, and it's going to equal, the silver is the one we know, This is his reduction. We have him written as an oxidation, so I'm going to flip the sign on that and use a negative 0.8. Negative 0.80 volts plus X. X must be whatever's happening to the platinum. And I just solve it, and I get 1.18 volts for the missing platinum. Okay. When I want the best oxidizing agent. When I see oxidizing agent, I immediately think that's the guy who really wants to be reduced. Because what he's going to do to the other guy is oxidize the other guy. So, who really wants to be reduced? It's really lucky that this is in terms of reduction, because this whole table is in terms of reduction, so I don't even have to think very hard about it. I just think, who really wants to be reduced? The guy at the very top with that big positive voltage. That really wants to happen. So F2 gas, F2, really wants to be reduced.